The $11 a day welder who saved America 50 million hours. March 1941. Mare Island Naval Shipyard, Vallejo, California. The welding torch hissed and crackled in the dim submarine construction bay as Edward Theodore Nelson, an $11 a day welder, watched 12 men struggle beneath the wooden deck planking. His jaw tightened. His notebook, worn and grease-stained, lay open beside his welding hood. Scrawled across the page in frustrated handwriting, "There has to be a better way. This is madness." Nelson had just witnessed something that made his blood boil. A dozen skilled workers had spent an entire 8-hour shift installing a single section of deck planking, hours upon hours of labor, just to secure wooden planks to steel frames. And tomorrow, they would do it again. And the next day, and the day after that. What none of the Navy supervisors knew was that this frustrated welder had already solved their problem. And what Nelson didn't yet know was that his simple solution, rejected and dismissed by his superiors, would soon save the United States Navy more than 50 million man-hours and fundamentally change naval construction forever. The date was March 5, 8 months and 22 days before Pearl Harbor. War was coming. Everyone at Mare Island knew it. To understand why Nelson's frustration mattered, we need to go back to the beginning. Mare Island Naval Shipyard stretched across 635 acres along the Napa River in Vallejo, California, 25 miles northeast of San Francisco. Founded in 1854 by Commander David Glasgow Farragut, it was the first United States Navy base established on the Pacific Ocean. By early 1941, Mare Island had evolved into the premier West Coast submarine construction facility. The yard operated around the clock, 3 shifts of workers, 7 days a week. Submarine construction had accelerated dramatically as tensions mounted with Japan. The yard employed approximately 12,000 civilian workers in early 1941, a number that would eventually swell to nearly 50,000 by 9. Among those 12,000 workers was Ted Nelson, employee number 3. He earned $11 per day, working the day shift from 7 in the morning until 4 in the afternoon. His job was welding, primarily on submarine hulls and internal structures. He was good at his work, fast, precise, but increasingly frustrated by what he saw as wasteful inefficiency. Ted Nelson, 36 years old, California-born, had earned his mechanical knowledge the hard way. 15 years in machine shops across California, 15 years of learning how metal behaved, how electricity flowed, how problems could be solved if only someone would listen. He wasn't a college-educated engineer, he was a tradesman, a mechanic, a man who understood machines because he worked with them every single day. The problem was everywhere he looked: wooden deck planking installation on submarines, destroyers and aircraft carriers. The Navy specified wooden decks for several practical reasons. Wood provided better traction than steel in wet conditions. Wood was quieter for crew movement, critical on submarines trying to avoid enemy detection. Wood provided some insulation against the cold steel beneath, and in the event of fire, wooden decks could be more easily repaired or replaced than welded steel plates. But the installation method was archaic, labor-intensive, painfully slow. The standard procedure, unchanged since the First World War, proceeded in a series of complicated steps. First, workers would drill holes through the wooden planks at precisely measured intervals. These holes would be countersunk to allow the heads of the attachment bolts to sit flush with the deck surface. Next, workers would position the planks on the steel deck framework. Then came the nightmare. Workers had to construct extensive scaffolding beneath the deck, inside the submarine or ship compartments. Multiple levels of platforms were required to give workers access to the underside of the steel deck framework. Once the scaffolding was in place, workers above and below would coordinate to insert long threaded bolts down through the wooden planks and through corresponding holes in the steel framework. Workers below, standing on scaffolding platforms in cramped, dark spaces, would thread nuts onto the protruding bolt ends. They would tighten these nuts with wrenches, pulling the wooden planks firmly against the steel framework above. Finally, workers topside would fill the countersunk holes with wooden plugs, creating a smooth deck surface. The entire process was repeated for every section of decking. On a submarine, there might be several hundred square feet of wooden decking requiring thousands of individual attachment points. The labor requirements were staggering. A typical submarine deck installation required a crew of 12 to 16 men working for 5 to 7 days. The scaffolding alone took 2 full days to construct and another day to dismantle. Ted Nelson had performed this work dozens of times. He had spent countless hours standing on scaffolding platforms, threading nuts onto bolts in cramped submarine compartments barely 4 feet high. His back ached from the constant bending. His knuckles were scarred from slipped wrenches. His patience was exhausted. But more than personal discomfort drove his frustration. He could see the bigger picture. War was coming. The yard was already behind schedule on submarine construction. The Navy needed boats in the water, not sitting in dry dock waiting for deck installation. Every day of delay was a day closer to conflict. America was not ready to fight. And Nelson knew there was a better way. He had been thinking about the problem for months, turning it over in his mind during the long hours of routine welding work. The solution seemed obvious to him. Instead of bolting from above and threading nuts from below, why not weld attachment studs directly to the steel framework? Weld from one side only. From above. No scaffolding required. No nuts and bolts. No workers cramped in compartments below. Just fast, strong, permanent welds. The concept was simple. A threaded stud, essentially a headless bolt, could be welded to the steel deck framework in a fraction of a second. The wooden planks would have threaded inserts or specialized nuts to attach to these studs. The entire operation could be performed from the top side only. No scaffold, no below-deck work, no coordination between crews above and below. Nelson had seen stud welding before in a limited form. The technology existed for horizontal flat plate welding. A small pile of flux powder would be placed on a flat steel surface. A stud would be positioned in the flux. An electrical arc would fuse the stud to the steel. But this method only worked on horizontal flat surfaces. The flux powder would simply fall off vertical or overhead surfaces. And naval construction required welding in all positions: vertical, horizontal, overhead, at all angles. This was the problem that had puzzled welding engineers for 20 years: how to make stud welding work on non-horizontal surfaces. Nelson thought he had the answer. It was so simple he almost laughed when the solution came to him. Instead of loose flux powder, encase the flux in a small ceramic cap. Attach the cap to the end of the stud. The flux stays in place regardless of position. He sketched his idea in his notebook. A handheld welding gun, a spring-loaded mechanism to press the stud against the steel surface, an electrical trigger to create the welding arc, a disposable ceramic flux cap on the end of each stud. The whole operation would take less than 1 second per stud. One worker could install dozens of studs in the time it currently took to install a single bolted connection. He took his idea to his supervisor, a Navy lieutenant named Morrison. The meeting lasted less than 5 minutes. Morrison barely looked at the sketches. "We have established procedures, Mr. Nelson. We follow Navy specification. If you want to weld instead of supervising bolt installation, stick to your current assignments." Nelson tried again, approaching the shipyard's chief welding engineer, a civilian contractor named Hartwell. He explained the time savings, the labor reduction, the elimination of scaffolding costs. Hartwell was more polite than Morrison, but equally dismissive. "Son, people a lot smarter than you and me have been trying to solve this problem for 2 decades. If it was that easy, someone would have done it already. Besides, the Navy has specifications. We can't just change procedures because a welder has an idea. You need approval from Bureau of Ships in Washington. You need engineering studies. You need prototype testing. That takes years." "We don't have years," Nelson protested. "We need submarines now." Hartwell shrugged. "That's not my problem, Mr. Nelson. My problem is building boats according to approved specifications. Your problem is doing the welding work you're paid to do." Nelson left the meeting angry and disillusioned. He had offered them a solution that could save thousands of hours per submarine. They had dismissed him without serious consideration, not because his idea was flawed, not because it wouldn't work, but because he was just a welder, because changing procedures required paperwork and approvals, because innovation was less important than following established protocol. He made one more attempt, writing a formal letter to the shipyard commander, Captain Thomas Withers. The letter was carefully composed, explaining the current inefficiency, proposing the stud welding solution, estimating time and cost saving. He submitted the letter through proper channels, following the established procedure for worker suggestions. 3 weeks later, he received a reply, a form letter thanking him for his interest in improving shipyard efficiency, a polite explanation that all technical proposals were evaluated by the Bureau of Ships Engineering Review Board, a notation that his suggestion had been forwarded for consideration, a realistic assessment that the review process typically took 18 to 24 months. By then the war might already be over, or lost. Nelson crumpled the letter and threw it in the waste bin. That evening he made a decision that would change his life and alter the course of naval history. If the Navy wouldn't listen, he would build it himself. He would prove his concept worked, then they would have to pay attention. He cleared a space in the garage behind his small cottage in Vallejo. His wife Emma watched with concern as he began collecting scrap steel and welding equipment. "Ted, you're going to get yourself fired," she warned. "You're supposed to be working on Navy projects, not your own inventions." "This will help the Navy," he replied. "They just don't know it yet." Over the following weeks, working evenings and weekends, Nelson constructed his first prototype stud welding gun. The design was crude but functional. A pistol grip handle, a spring-loaded plunger to hold and press the stud, an electrical trigger connected to a welding power supply, a quick-release mechanism to load new studs. The most critical innovation was the flux cap. He experimented with different ceramic materials, different flux compositions, different cap designs. After dozens of tests, he developed a cap that held the flux securely, allowed proper arc initiation, and could be manufactured cheaply. By May 1941 he had a working prototype. He tested it on scrap steel in every position imaginable: horizontal, vertical, overhead, at angles. The gun worked flawlessly. A stud could be welded in less than 1 second. The weld strength exceeded that of traditional through bolts, and most importantly it required no below-surface access. He brought the prototype to work, demonstrated it to several fellow welders during lunch break. They were impressed, excited. "This is going to save us so much time," one remarked. "You need to show this to Morrison," another suggested. Nelson shook his head. "I already showed Morrison. He wasn't interested." "Then quit and start your own company," a third welder advised. "Sell your gun to shipyards across the country. You'll make a fortune." The idea hadn't occurred to Nelson. He was a welder, not a businessman. He had no capital, no manufacturing facility, no business experience. But the more he thought about it, the more sense it made. If the Navy wouldn't use his invention, maybe private shipyards would. On June 20, 1941, Ted Nelson submitted his resignation to Mare Island Naval Shipyard. His supervisor tried to talk him out of it. "Nelson, you're a good welder. Don't throw away a steady job for some crazy invention." But Nelson's mind was made up. "I'm going to build welding guns," he told Morrison. "And when the Navy comes back asking to buy them, I hope you remember this conversation." He left Mare Island with $11 in his pocket, a garage full of tools, and a conviction that his invention would succeed. If you're fascinated by these untold stories of wartime innovation, make sure to subscribe to our channel and hit the notification bell. We dive deep into the forgotten engineering achievements that changed history, from the factory floors to the front lines. Your support helps us bring these stories to light. He incorporated the Nelson Specialty Welding Equipment Corporation on July 4. He borrowed $95,000 from the Reconstruction Finance Corporation, a government lending agency established during the Depression to support small businesses. With that capital he rented a small workshop in Vallejo and began manufacturing stud welding guns. The first months were difficult. He had no customers, no reputation, no distribution network. He made sales calls to local machine shops and small fabrication companies, demonstrating his gun, explaining the time savings. Most were skeptical. A few were interested enough to try a demonstration unit. Slowly, very slowly, orders began to come in. By September 1941 he had sold 18 welding guns and several thousand flux-capped studs. Then on December 7, 1941, everything changed. Pearl Harbor. The Japanese attack destroyed or damaged 8 battleships, 3 cruisers, 3 destroyers, and 188 aircraft. 2,403 Americans died. The United States was at war. Suddenly, shipbuilding wasn't just important, it was a matter of national survival. Within days of Pearl Harbor, the shipbuilding industry exploded into frantic activity. The Kaiser shipyards began building Liberty ships at an unprecedented pace. Mare Island Naval Shipyard received emergency orders for submarine construction. Bethlehem Steel and other private yards started working triple shifts, and every single one of these facilities faced the same problem: how to build ships fast enough. The traditional methods were too slow, too labor-intensive, too wasteful of precious time. Ted Nelson's phone began ringing. Shipyard purchasing agents who had dismissed his invention weeks earlier now wanted to place large orders. The Kaiser shipyards ordered 50 welding guns and 10,000 studs. Bethlehem Steel ordered 40 guns. Even Mare Island Naval Shipyard, where he had been rebuffed just months earlier, placed an order for 60 guns and 20,000 studs. Morrison, his former supervisor, handled the purchase requisition. There was no apology, no acknowledgement that Nelson had been right, just a terse official order and a request for prompt delivery. By January 1942, less than 1 month after Pearl Harbor, Nelson's small workshop couldn't keep up with demand. He was receiving orders faster than he could manufacture products. He needed a real factory, more workers, better equipment. He leased a larger facility in San Leandro, a few miles south of Oakland. By March 1942, he employed 20 workers. By June, 50. By September, 150. The factory operated around the clock 7 days a week. Welding guns rolled off the assembly line at a rate of 30 per day. Stud production reached thousands per day. Every major shipyard on the West Coast was now using Nelson's stud welding equipment, and the reports coming back were extraordinary. A submarine deck installation that previously required 12 workers and 6 days could now be completed by 3 workers in 1 day. The elimination of scaffolding saved 2 additional days and freed workers for other tasks. The welds were stronger than traditional bolted connections. The wooden deck planks could be removed and replaced more easily for maintenance or repair. At Mare Island Naval Shipyard, submarine construction accelerated dramatically. The yard completed 17 submarines between 1941 and 1945, with an average construction time that steadily decreased as new techniques were implemented. Stud welding wasn't the only innovation, but it was a critical piece of the efficiency puzzle. By mid-1942, stud welding was being used not just for deck attachment, but for dozens of other applications: pipe hangers, cable supports, equipment mounts, bulkhead attachments. Any situation where a fastener needed to be attached to steel structure, stud welding provided a faster solution. The Navy Bureau of Ships, which had initially ignored Nelson's proposal, now studied his process intensively. Engineering teams analyzed weld strength, durability, and failure modes. The results confirmed what Nelson had known all along. His welds weren't just faster than traditional methods, they were actually superior in strength and reliability. On November 19, 1942, just 11 months after leaving his $11 a day welding job, Ted Nelson received a formal visit from a delegation of Navy officers. They came to his San Leandro plant unannounced. A group of 5 men in dress uniforms. Captain Harrison, representing the Bureau of Ships, did the talking. "Mr. Nelson, we're here to inform you that the Navy has completed evaluation of your stud welding process. We've determined that your invention has saved the United States Navy an estimated 5 million man-hours in submarine and surface ship construction over the past 10 months. That number is expected to increase substantially as more shipyards adopt your technology." He paused, then continued. "On behalf of the Secretary of the Navy and the United States government, I'm authorized to present you with a citation for exceptional contribution to the war effort." Nelson was stunned. They had rejected his idea. They had ignored his proposal. They had forced him to quit his job and risk everything to prove his concept. And now they were giving him a citation. Captain Harrison must have seen the conflict on Nelson's face. "I understand you submitted a proposal to Mare Island in early 1941, Mr. Nelson. I've reviewed that file. Your proposal was not properly evaluated at the time. That was a mistake, and I apologize on behalf of the Navy. However, your decision to develop the technology independently has resulted in faster deployment than would have been possible through the normal procurement process. Sometimes the best way to serve your country is to ignore official channels and just solve the problem." Nelson accepted the citation with mixed emotions: pride in his achievement, vindication for his perseverance, but also frustration at the bureaucracy that had nearly prevented this innovation from happening. The war continued. Production demands increased. Nelson's company expanded again, opening a second manufacturing facility in Camden, New Jersey in March. This East Coast plant supplied shipyards in New York, Philadelphia, Norfolk, and Charleston. Before we continue with the lasting impact of this innovation, if you haven't already subscribed to our channel, now's the perfect time. Hit that subscribe button and turn on notifications so you never miss stories like this one, where individual ingenuity changed the course of history. By mid-1943, Nelson Specialty Welding Equipment Corporation employed over 400 workers and generated annual revenue of approximately $4 million. Ted Nelson still spent 16 hours a day in the factory, still dressed in shop workers' tan pants and shirt, still drew a modest salary of $1,000 per month. All profits were reinvested in expansion, equipment, and loan repayment.
but his impact on the war effort was incalculable. The Navy's estimate of 5 million man-hours saved by late 1942 was just the beginning. As the war progressed and stud welding became standard practice across all naval construction, the time savings multiplied exponentially. By 1943, stud welding was being used not just on submarines but on aircraft carriers, battleships, cruisers, destroyers and hundreds of smaller vessels. The Essex-class aircraft carriers built by Newport News Shipbuilding and other yards used Nelson stud welding extensively for flight deck attachment and interior fittings. Each carrier required approximately 20,000 studs. The Navy built 24 Essex-class carriers during the war. The most dramatic impact was in submarine construction. Portsmouth Naval Shipyard in New Hampshire became the champion submarine builder, completing 79 submarines between July 9. Portsmouth's success was built on multiple innovations, but stud welding was a critical enabling technology. At the peak of production, Portsmouth completed 32 submarines in 1944. This was approximately one submarine every 11 days. Across all yards, the United States built 203 submarines during World War II. Each submarine required thousands of stud-welded attachments. Each stud saved minutes of labor time. Multiply those minutes by thousands of studs per submarine by hundreds of submarines and the time savings reached staggering proportions. 50 million man-hours. Let that number sink in. 50 million hours is approximately 5,700 years. If one person worked 8 hours a day, every day, it would take over 19,000 years to accumulate 50 million hours. This time savings came from one simple innovation, a spring-loaded welding gun and a ceramic flux cap. The time savings translated directly into ships in the water faster, more submarines hunting Japanese convoys, more destroyers escorting Atlantic convoys, more aircraft carriers launching strikes, more landing ships, delivering Marines to hostile beach. Every ship delivered faster meant more combat power, more supplies delivered, more lives saved. On May 11, 1943, the Secretary of the Navy presented the Nelson Specialty Welding Equipment Corporation with the Army-Navy Award for Excellence in Production. The award was created in July 1942 to recognize companies whose production facilities achieved outstanding performance in manufacturing war equipment. Only about 5% of companies engaged in war work received this honor. Plants that maintained outstanding performance for 6 months after receiving the initial E award were granted a star to add to their pennant. The Nelson Company earned its first star in November 19. By the end of the war, the Nelson Specialty Welding Equipment Corporation had earned 2 E awards with stars, one of only a handful of companies to achieve this distinction. The citations specifically noted the estimated 50 million man-hours saved in naval construction. But Nelson's invention had another unexpected benefit. The stud welding process required less skill than traditional bolt installation or conventional welding. With minimal training, new workers could perform stud welding operations safely and effectively. This was crucial as the war progressed and labor shortages intensified. Women entered the shipyards in unprecedented numbers. Mare Island Naval Shipyard, at its peak, employed almost 50,000 workers including 9,000 women. Kaiser shipyards employed hundreds of thousands, with women making up nearly 30% of the workforce. These women needed tools and processes that could be learned quickly and performed safely. Stud welding fit that requirement perfectly. By August 1945, World War II ended. The massive military production machine began winding down. Contracts were cancelled, workers were laid off, shipyards closed or converted to peacetime production. The Nelson Specialty Welding Equipment Corporation faced an uncertain future. Military orders dried up almost overnight, but Ted Nelson had prepared for this moment. During the war years, he had been thinking about peacetime applications for stud welding. The technology wasn't limited to shipbuilding. Any industry that fabricated steel structures could benefit from faster attachment methods. Nelson pivoted to civilian markets. He marketed his stud welding systems to construction companies, steel fabricators and industrial manufacturers. The post-war construction boom provided new opportunities. America was building highways, bridges, skyscrapers and all required steel fabrication and attachment. In 1950, Nelson sold his company to TRW, a large industrial conglomerate. The sale made Nelson financially secure and allowed him to retire from active management. But the Nelson name remained on the product. TRW continued to market Nelson stud welding equipment, maintaining the brand recognition Nelson had built. Today Stanley engineered fastening manufacturers and markets Nelson stud welding products globally. The technology pioneered by Ted Nelson in his garage in Vallejo remains in use worldwide. Modern stud welding is more sophisticated than Nelson's original design, but the fundamental principle remains the same: a stud, a flux cap, a spring-loaded gun, and an electrical arc, 1 second per stud, no scaffolding required. Ted Nelson lived until 1994, dying at age 89. He lived long enough to witness the end of the Cold War and the transformation of the world his generation had fought to preserve. He saw stud welding become standard practice in shipbuilding. He saw it adopted by industries worldwide. He saw his name become synonymous with a welding process. The statistics of his achievement tell only part of the story: 50 million man-hours saved, 2 Army-Navy awards, thousands of ships built faster, billions of studs manufactured. But numbers cannot capture the full impact. Behind those statistics were sailors who returned home because their submarine was completed in time to join the fleet, Marines who survived because landing craft were available for their assault, families who weren't torn apart because the war ended soon. The true measure of innovation isn't just efficiency gained, but lives preserved. Ted Nelson, the $11 a day welder who was told his idea was impractical, saved more lives than many combat heroes. He did it not with weapons, but with welding. Not through destruction, but through construction. The rejection he faced wasn't unique. History is filled with innovators dismissed by established authorities. What made Nelson different was his refusal to accept rejection. He didn't argue with bureaucrats. He didn't waste time trying to convince skeptics. He simply quit his job, risked his savings, and proved his concept worked. Then the market did the convincing for him. This is the essence of American innovation: not waiting for permission, not following established procedure, not accepting that things must be done the way they've always been done, just identifying a problem, developing a solution, and having the courage to implement it regardless of institutional resistance. Ted Nelson started as an $11 a day welder. He ended as a millionaire industrialist whose technology changed naval construction forever. But he never forgot his roots. He never put on airs. He never claimed to be anything more than a mechanic who saw a problem and fixed it. The next great innovation might come from someone just like Ted Nelson, a worker in a shipyard, a mechanic in a garage, someone the experts dismiss as unqualified, someone bureaucrats tell to follow procedures, someone official channels assure is wasting time on an impossible problem. History suggests we should listen to these people, not because all their ideas will work, but because the occasional idea that does work can change everything. What questions are you asking today? And when the experts tell you it can't be done, when the bureaucrats tell you to follow procedures, when the skeptics dismiss your idea, will you have the courage to prove them wrong? Ted Nelson did exactly that. 80 years later, welders around the world still use his invention every single day.